Okay, so here's what your two graphs should look like for number 2. Here's what your two graphs should look like for number 3. And again, make sure you're answering these questions, but you don't need my help for that. Or if you do, you can raise your hand. Okay, so now we are on this last page. And although it might look intimidating, this is totally doable. So number 4 says write a system of equations that has no solution. Wait, I've never written a system of equations before. Wait, I don't know what it should look like. Wait, I don't know what it means by no solution. You do. Look back at the last 3 pages that we have done. These are 2 parallel lines. This is a system of equations that has no solution. These are 2 parallel lines. This is a system of equations that has no solution because they never cross. Here are 2 parallel lines. This is a system of equations that has no solution because these 2 lines never cross. There are 3 examples. You don't need to graph it. You just need to write a system of equations. I would recommend starting with y equals something, x plus or minus something, and there should be 2 equations. You have 3 examples. Yours should not be the same, but they should be following the same format. Number 5 says, how can you tell if a system of equations has a solution or not? Well, we just saw 3 examples of systems that don't have a solution. What did they all have in common? And if we think back to what we did on Monday, we graphed some equations, not Monday, Tuesday. We graphed some equations that did have solutions. For example, this one. That's the solution. So what's the difference here between a system of equations that has a solution or doesn't have a solution? And how can you explain that in words? And last, so you're doing that one on your own. Lastly, here we have some equations that are not in slope-intercept form. And it's asking if it has a solution. Now, when it's asking if it has a solution, we want to be looking for the slope. Do we see the slope exactly here? No, because it's not in this format, y equals mx plus b. It's in standard form, which is ax plus by equals c, which is where a and b, ax plus by equals c, where a and b and c are numbers. So since we can't see the slope here, we're going to have to convert our equation so that we can see the slope. I'm going to do number 6. You need to pick either 7 or 8 to do on your own using the same format. I have 2 equations. I have to switch both of them. I'm going to start with this one. I want it to look like this, so I need to get y by itself. I'm going to start by subtracting 6x from both sides. This makes a 0, which means I'm left with negative 2y equals 5 minus 6x. Can't put those together because this has an x and this does not. I can, though, flip this around. This is 5 minus 6x, which is the same as 5 plus negative 6x. And then if I flip those, this starts to look like an equation that I'm familiar with. So now I need to get y by itself. I divide by negative 2, dividing everything by negative 2. This makes a giant 1, and I'm left with y equals negative 6 divided by negative 2 is positive 3 plus negative 5 over 2. So what is my slope in that equation? My slope, I can now see it, is 3. We're going to do the same thing over here. So here's our other equation, the second one. We want to get y by itself, minus 4x minus 4x. This makes a 0. then I get negative 3y equals 5 minus 4x. I'm going to flip these around. So this is plus negative 4, and I get negative 4x plus 5 equals negative 3y. How do I get y by itself? I divide by negative 3. Dividing everything by negative 3 is the same as doing negative 4 over negative 3x plus 5 over negative 3. Same thing. Dividing everything by negative 3, dividing each thing by negative 3. This here makes a giant 1. And we get y equals a negative over a negative. That is a positive plus negative 5/3. The slope